Hi guys. Just to give you a bit of context before the video is actually starting, it's basically a replay of a workshop I've done for Ring Zero because I'm giving a browser fuzzing training in Las Vegas in August 2022. So I've made this quick workshop. It's like 1 hour and a half, something like that, about introduction to V8 fuzzing using grammar-based fuzzing. So basically, just to give you a quick overview, in this workshop, in the following video right now, you're gonna basically see, get a bit more context about what is V8, what is doing, and how can you retrieve a version of V8 that is already compiled with AddressSanitizer in order to detect bug on the shelf. And then I'm explaining how to use Dharma, that is a famous grammar-based fuzzer, in order to create your own JavaScript grammar and basically generate some JS file that you hope will find some bugs. So that's basically it. Please enjoy the video. You have all the link on the description, all the link to retrieve the different sources and so on. Let me know if you have any question. Don't forget to subscribe and like, and yeah, enjoy the video. Bye. Hi everyone, just saw some message on the chat, so I send you some setup instruction. I think you received that by mail. It seems that we have already something that is not working, so let me check just to be sure. No, it should work. So the wget command should work properly. Just be sure to get all the character, I think. Okay, so yeah, as Sherry mentioned, we're going to do a workshop. So it's kind of an introduction to V8 JavaScript engine grammar-based fuzzing. So basically, we're going to do grammar-based fuzzing against the V8 JavaScript engine. It's the JavaScript engine used in Chrome and also in some other browsers like Edge, for example, the new version. So basically, my goal will be to give you a bit of intro about what is a browser, Chrome and V8, to give you a bit more detail. And then I will explain you grammar-based fuzzing and what we're going to do and why we are using grammar-based fuzzing. And then I will do an introduction to Dharma, that is one famous grammar-based fuzzer. It's one of the most famous one when we are dealing with JavaScript fuzzing. The other one is Tomato. So it's kind of similar, to be honest. I'm using Dharma in that case, and I'm also teaching in the training using Dharma because I find it more modulable, but I mean, you can also use Tomato. So if you have any question, don't hesitate to ask on the chat, and I will be really happy to answer. And I think we can start. If you have any question, so yeah, I already told you, and all the slides and content, I don't know how we're going to share that, but otherwise, I mean, I will upload the whole package and give the link to Cherry, and she will be able to send it back to you during the day or tomorrow maximum. Okay. So let's start. So introduction to V8 grammar-based fuzzing. So that's the goal of today. Introduction to browser, really quick, just also to discuss the attack surface, Chrome and V8, fuzzing with Dharma, and also a tiny Python script for automation, just for you to have something to start with. So first, we need to define what is a browser. So that's something everyone is using, basically. the main important part for us as a vulnerability researcher is to understand that a web browser is fetching a lot of content and a lot of different content from the web. So everything that basically you are fetching can be considered untrusted. So that's really important. There is different kind of data. You have some web resources like HTML, XML, CSS, JavaScript, and so on. Some of those data and most of those data will be parsed. Some of them will be interpreted, and so on. So you start to understand that the more data you handle, the more type of data you handle, the more complex your browser will be, the more parser you have. And if you are familiar with vulnerability research, parsers are definitely the go-to when you start to look for bugs. So you have the parsing part, and you also have, of course, the interpretation, execution part, like interpreting the data that is inside that come in place. So that's the common way we actually define the browser architecture. So it's separated in multiple components. You have the user interface. So that's basically your address bar, your back forward button, and everything. So that's the UI dedicated to the browser. Then we have what we call the browser engine. So it's the bridge between the UI and the rendering engine. The rendering engine is this part, so it's the one in charge of rendering the content of a website. So it will basically interpret the HTML, the XML, the CSS, and so on, and it will render the page. So it will be this one that will be in charge of rendering the page. Basically, this rendering engine will need to communicate with the JavaScript engine that will be the one in charge of all the JavaScript and WebAssembly code. So it will be this part that we're going to target for the training. And then you have a bunch of other components. You can think of the networking part that will handle all the internet communication. And most of the time, depending on the browser, it could even handle stuff like TCP/IP and so on. In some hosts like macOS, for example, it will be basically direct syscall and communication to the host that will be in charge to do the job. So this kind of stuff is really a bit more custom depending of the browser, because it's also really depending of the host that you are using. Then we have the UI backend. So it will be the one in charge of doing some widgets, some stuff like that. And then we have all the data persistent stuff. So you think of everything that needs to be stored for a website, like cookie, what we call the storage, IndexedDB, file system, and so on. So persistence of data. You can also simplify that like that. We are fetching with the network layer. We are processing with the render engine, the JS engine, and the UI backend, because we are processing, in the case, we are processing data and file and content. We display with the user interface and the browser engine, and then we store with the data persistence part. So that's the classical architecture in detail. Usually the JS engine is part of the rendering engine and so on. But I mean, in general, that's the different components, and that's the way we are separating them. So why it's interesting for us to attack a web browser? So there is really a lot of reason. In the recent years, we saw a lot of offensive security company like exploit shop and brokers that basically pay for ODAs and mainly exploits. You have all the guys from defensive security. You can think of the Project Zero team. You can think of vulnerability research programs and bug bounty programs. You have one of the most famous one is basically the one from Chrome that is paying a lot of bug bounty. And then you also have the VR program with ZDI SSD disclosure that leads to, in the same way, competition and challenges like Point One that is organized by ZDI. So you really have a lot of people that is involved in this industry and that is actually targeting these targets. I will not ask you why you are doing that. It's really up to you. What I really like with that is you have at the same time people that are really focused on vulnerability research and fuzzing like me. And on the other side, I have some friends that are really focused on exploit development. And it's really completely different than what I'm doing. And we are basically targeting the same target. So that's really interesting. So, let's discuss now about the attack surface. So I told you a browser is really complex. There is multiple of them. Typically in the training, we are discussing mainly about Chrome. We are discussing about WebKit and JavaScript core, so for Safari, but not directly Safari. And we are targeting also Firefox. On all those browsers, they are kind of similar in what they are doing, but they are definitely not similar in their code base. Sorry. As an example, just in terms of line of code, you can see that Chrome is really enormous. To give you an idea, Chrome is actually bigger in terms of code base than the Linux. It's like third the size of WebKit, and so on. So you start to understand that, of course, the more line of code you have, the more bugs you will have. And again, the more complex is your target, the more chance you will get any bugs. So fuzzing is definitely the most efficient technique to find bugs. There is no debate on that. It just we are able to find complex bugs automatically without looking at like 15 million line of code. So it's definitely a go-to. So the main components that are really interesting, if we take a look at the latest vulnerabilities that have been released, we can see that it was mainly on the JavaScript engine. We also have some of them on the DOM engine. So that's the part in charge of the rendering, like HTML, CSS, and so on. We have some web audio, IndexedDB, so storage, WebGL. Then we have some UXSS, so more on the UI side, I would say. And again, some other stuff on the storage. I really like this other graph that is basically showing you over the years which component have actually provide the more bugs. And what we can see is that in general, the renderer with the DOM and the HTML5 always contains some bugs. And the second one is usually the JS engine that also a lot of bugs have been reported inside this one. So that's also why we're going to target this one. As I mentioned, the JS engine is not just in charge of JavaScript, as the name suggests, but since 2017 is also in charge of the WebAssembly. So it's really important. That's a really huge part of the network. The process and the code base. So we have a huge part of parsing and execution that is inside. So I just saw on the chat that some of you told me that the Google API is not working. So that's unexpected because for me, as you can see, it seems to work. So yeah, I mean, it's downloading. That's a bit weird. I don't know why you don't have that. Are you sure you got the exact same one than me? Oh yeah, sure. If you copy past that on the browser, it will not work. That's why I'm providing you the wget. I mean, if you copy past that, it will not work. It will detect you are basically accessing to files that is not supposed to be accessed like that. So either you can use the link provided by Yusuf on the chat. That is basically the same, but using your browser, or you can use wget and use the one I'm providing. Okay. So let me know if you still have any issue with that. Yeah, Alexandro. So I'm completely new to Zoom, so I don't know how to accept that. Jerry? What am I supposed to do when someone is raising his hand?
Yes. Okay, it's a misclick. Sorry, next time that happens, I'll give that person the right to speak, and then they can just ask a question.
Okay. Yeah. No worries. I mean, I just don't know how to accept that. Okay. No worries. So yeah. So let me know if you get any issue with downloading the stuff. It's like 2 GB to download, and it should be good. I mean, we will see later. Oh yeah, as Sharon mentioned, by default it's just host and panelist. So that means you are doing like direct message to us, I suppose. If you want to speak for everyone, you just need to select everyone in the chat. Okay, good. So let's talk right now about Chrome and V8. So all the slides, I saw some question on the Discord chat. I mean, we will provide you all the slides and everything. Basically, those slides actually come from the training. I've made it simple for today. So I extract part of the training just to give you also an idea of how I'm working. That's the kind of slides I'm doing. It's maybe a bit heavy, but I mean, that's my way to do. I'm always providing like some further reading section because I find it really useful to basically provide some additional link and resources for people to learn more about the subject on the slide. So yeah, no worries. We will give you everything. So for Chrome and V8, more specifically, so Chrome is actually the browser developed by Google Chrome, of course. And basically this browser was using WebKit before that, and they decided to fork WebKit, and they create their own stuff from that. So basically, we have part of Google Chrome that is actually completely free, and it's a browser as itself. It's Chromium, so it's a free and open source web browser. And on top of that, they are adding some stuff, some custom and specific stuff for what they need. Typically, you can think of all the applets, the integration with all the Google services that is directly inside Google Chrome and so on. All of that is basically on top of Chromium. That is really the core of the browser. Inside Chromium, you have multiple components. So as I mentioned, you have Blink, that is actually the rendering engine, and it's a fork of WebKit. Then you have V8, that is the JavaScript interpreter of Chrome. And you have a bunch of third-party libraries and some other stuff that could be developed by Google, or that could actually be completely external, like real third-party project. And depending of all those libraries are basically specific for one usage. So you can think of libpng, fmpeg that will be used mainly for audio and video stuff in the browser. You have libxml, Skya, and so on for all the graphic stuff with Angle and so on. So in our case, we want to focus on V8, that is the JS and the WebAssembly engine of Chrome. It's written in C++. It's, as I mentioned, it's part of Blink code base, so it will be exactly inside the same code base as the rendering engine, even if it's something more specific. It's used in Chrome, but not just in Chrome. It's also used like in Node.js, and it's also used in Edge, the Edge browser that is actually also using Chromium, and so on. Something really important to know is that in general, I mean, JavaScript execution is always about trade-off. And it's something really important to understand because it could look weird to make something as complicated over the time and to really complexify as a maximum and try to optimize a maximum the JS execution if you are not aware of that. So basically the first trade-off will be you're going to receive some JavaScript code. It will be parsed, and then it will be converted into what we call the AST, the abstract syntax tree. So it's a simplified representation of the JavaScript code. The main reason we have that is because JS is it's not typed, and it's text-based format. So we need to parse it and convert that into tokens and kind of instruction equivalent. So once we got this AST, usually what will directly happen is that we're going to provide that to an interpreter. So this interpreter will take this representation and directly interpret, meaning that if the instruction is add, it will do an addition directly. Okay. So that's the most simplified way and the most simple JS engine you can get. And over the time, they find out that in some cases, there is plenty of stuff that could be optimized, and this one could be one of them. And they decide to develop what we call JIT engine, JIT compiler. So the main goal will be over the time, if the code become hot and really interesting, we're going to give that to a compiler, and this compiler will generate some optimized assembly code that will be executed. So JIT code, just in time code. So that's the way it works. If this code at the end is not fitting anymore, it's not reaching the goal, we need to go back to interpreter and so on. So this way is like the most simple way we can have a JS engine. That's the way V8 is working, or at least was working until recently. They decide recently to add more JIT compiler. To give you an idea, on WebKit, there is a 3 JIT compiler. On Firefox, I don't remember how many they have. They got multiple of them, or at least multiple passes, and so on. So right now on V8, you have those components. You have the JS interpreter that is called Ignition, that will basically, as I mentioned, take this AST and directly interpret that. You have the main optimization compiler that is called Turbofan. We have a dedicated compiler that is called Liftoff, that have been released maybe 2-3 years ago, I would say 2 years ago, dedicated for WebAssembly. We have Orinoco, that is the V8 garbage collector. It's written in C++. It's not like Rust. You are doing a lot of allocation and so on. So that's why we have a garbage collector. And recently, they released a Spark plug that is a non-optimizing transpiler compiler to simplify, it will convert the ignition bytecode, so the stuff done by the interpreter, and it will shift that into machine code that will be executed by the JS engine directly. So it's really something that is on the middle. The main goal on the long term, and the main goal of this tool is basically when we have ignition that is running, then we're going to optimize with turbofan. And if for some reason we need to de-optimize, that is something what we call bailout, we're going to execute the spark plug stuff that will be faster. So that's kind of the global architecture of V8. So over the time, you just start to see that it's starting to be more and more complex, the more deep we are going. And we are just targeting the JavaScript engine in that case. And it's already a lot, to be honest. So once we know that, when we are doing fuzzing, there is an important question to answer. And this question is, how are we going to do to find bugs? So the classical way we have for every stuff that is written in like C, C++, and even in Rust and other stuff, like everything that is using the LLVM backend for compilation is basically to use sanitizers, and mainly the AddressSanitizers. Most of the bugs you will find on a browser will be stuff related to memory corruption, like use after free, heap buffer overflow, out of bound read, out of bound write, and so on. So all those bugs could be detected automatically with AddressSanitizers. So the good part for us, usually you will need to download the source code. You will need to recompile everything from scratch, and basically add the good flag in order to compile with AddressSanitizers. In all cases, we are lucky enough for because the Chrome team is actually providing a version of and I mean, not just one version, a lot of versions of Chrome pre-compiled with AddressSanitizers. So that's the link I gave you. It will basically allow you to download a package that contains Chrome, Content Shell, and V8, and a bunch of other libraries. Everything compiled with AddressSanitizer. What that means for us is when we're going to do fuzzing on that, we will be able, if we're able to trigger any crashes, we will get an AddressSanitizer stack trace, and we will be able to detect there is a bug inside. So that's something really important because we are not just looking to do fuzzing and provide files to the target. We want to detect bugs, and that's what AddressSanitizer is there for. So there is a tool also called Omar Proxy, this one. The really good part is you can just specify which version of Chrome you want, and for example, this one, and we can do a lookup, and it will tell you, okay, that's the branch-based position. And if you remember the stuff I'm providing you right there, there is this number, and that's actually the branch-based position number. So that means if you are looking for some bugs that have been reported previously, you can perfectly just roll back and download a vulnerable version of that. The website for the CR bugs, so that's this one. You can take a look at that. That's basically the bug, all the bugs that have been found in Chrome and in V8 will be right there. And you can specify stuff like, give me one second, maybe I have that right there. So if you are looking for those specific stuff, you are looking for all the bugs that are critical or high or medium, and that got some rewards. And as you can see, there is some stuff that have been modified and opened recently. And I don't know, like this one, for example, this one is a use after free in the browser switcher, some stuff in the framework. And as you can see, they provide some address sanitizer, and especially they provide the Chrome version. So if you copy past that, you can go on Omar Proxy, look up, and you will get the branch-based position, that is this one. Then you can perfectly download the old version of Chrome, and then you can try to reproduce the bug. Usually, so in that case, this bug got 3K as a reward. There is some reproduction stuff to do, but it's on Chrome OS, so you need to also take care of that. Maybe it will be impactful. Let's take a look at this one, maybe more. So use after free, you have this version, that's the stack trace, 7K as a reward, and you have the proof of concept right there. So not available in that case, maybe it's just too recent, or maybe we can just download it. Yeah, you need to download it. So maybe like that. And let's open that. Yeah, give me 1 sec. I'm gonna find a way. Okay, and so that's the proof of concept for the POC I just mentioned. So as you can see, there is some HTML file, some JavaScript inside the script stuff, and then get element by ID, WebGL stuff, texture 3D, and so on. So there is some JS calls, and basically this sequence of JS calls are triggering in that case. Let me close that. In that case, it's triggering which... Oh, I think I close. Okay, wait a bit. Okay, good. Just put this bar right there. So in that case, this bug is triggering a heap buffer overflow. And as you can see, you need to also specify some flags, but we're going to see that later. So that's the way basically we are going to reproduce a bug. It's working pretty well. It's a really good technique, and that's actually nice to be able to go back in time and be able also to reproduce. That's basically what we're also doing on the training. During the training, we're basically trying to write fuzzers that will reproduce and trigger some existing bugs. So that's also why we're targeting some old version. The version I told you to download is basically an old version that is vulnerable to multiple vulnerability, of course. And we are basically trying to find some bugs inside. So once we got that, that's good. We can actually start to play with it. Either we can run Chrome directly, but the main issue when you are basically opening a Chrome, like we are inside this one, we are inside AddressSanitizer Linux debug, and inside this folder, you have a bunch of stuff. You have Chrome, as I mentioned, right there. And if you take a look, one of the first things you need to do is verify that you have a proper version of Chrome. So you can do like nm Chrome grep, and you are looking for ASAN, just to be sure that your Chrome is actually compiled with AddressSanitizer. So we are looking for strings and Mongol name especially that contain the name AddressSanitizer. So as you can see, that's the case. Sorry. Chrome is actually one of the tools available, but it's not the only one we have. So Chrome is right there. You can see that Chrome is like 1.1 gigabyte. If I'm running Chrome, it will open the UI and everything. It will be able to handle HTML file. And if we are fuzzing HTML file, that's okay. But in all cases, we want to fuzz JavaScript. So the really good part is that Actually, the Chrome team is also providing us a debug aid or debug aid that is a V8 minimalist debug shell that actually contain V8 and that is using V8. So it will be the easiest way for us to communicate and to fuzz V8, because basically we will provide to this tool D8 right there. We're going to provide it's as you can see, that's a shell for this specific version of V8, and we can do a equal I don't know, like hello, and we can do print a undefined, hello undefined, and so on. So that's the kind of stuff we can do. We have a JS shell in that case, and we can also, of course, provide some file. So let's say I want to provide a simple hello.js. It's a really simple hello world, nothing fancy. I can show you the code right there, hello.js. So as you can see, just print hello world. And we are getting the result right there. So in that case, what happened is that we provide a JS file that has been parsed and executed directly by D8. And since D8 is using the V8 and the V8 engine and the libv8 library, more specifically, we are able to execute some JavaScript code. So that's good. We already have a lot of stuff to deal with. What the next step is basically to leverage on this tool, on what we have, in order to generate some JavaScript file and provide that as an input to this tool. Just a quick reminder: this tool, so it's a minimal way for us to communicate to D8, as you can see. So in that case, it's really slow, tiny, because it's not statically compiled. So that's the sad part, but it's mainly because we're on debug. So it's basically using the libv8 that is somewhere, libv8, libv8 right there. So it's minimal compared to Chrome, and also Chrome in that case will also use libv8, so it's exactly the same. So we have a minimal version. It's also compiled with AddressSanitizer, so we are good to go. We can detect some vulnerability. So the next step is to provide files, and for that we need to create those files. So that's where Dharma come in place. When we are discussing about fuzzing web browsers, there is multiple techniques that can apply. So first of all, why we are using fuzzing is because it's, as I mentioned, the most efficient way to find browser bugs. Since the attack surface is really huge, it's way better for us to let a laptop or some CPU find the bugs more than ourselves in front of the screen. If you take a look at all the bugs that are found, like on cluster fuzz or even like on CR bugs and so on, there is really a lot that are found by fuzzers or by external researchers that are using some custom fuzzers. Not a lot of them have been reported manually, to be honest. And in terms of techniques, I don't know how familiar you are with fuzzing, but we have plenty of techniques available. On browsers, we can basically apply all of them. It's just depending on the target. If you are targeting a pure parsing library, in that case, it will make sense to use like coverage-guided fuzzing with tools like AFL, OnkFuzz, libfuzzer, and you're going to target specifically this library and this file format and so on. Make total sense. But when you are targeting some stuff that are what we call context dependent, meaning that if you are executing a line of code and then a second line of code, it will give you at the end a certain state internally. You will allocate some object, maybe. You will get some interaction and so on. And in the same way, executing like one line and after a second one and on this order is not the same than executing the second one and then the first one. Even if you are just creating object, the context will not be the same, the address for the allocation will not be the same, and so on and so on. Maybe the garbage collector, if you are doing that a lot, will actually be triggered and it will do some stuff and so on. So it's not deterministic. So that's why it's also really complex for us to do like classical coverage guided fuzzing, because we can perfectly have the exact same coverage, but just because we are not calling the stuff on the same order, we will not get the same state. So that's why we are using typically grammar-based fuzzing for that. So that's what we are using for when we want to fuzz DOM engine, like the rendering engine with HTML and so on. And also that's what we are using for JavaScript. The most famous fuzzer you will have for that are basically for grammar-based fuzzing. You have Dharma and Tomato, and also Freedom. That is another one. That's the most famous one. You have some kind of exception. You can think of Fuzzily, that is actually using coverage-guided fuzzing for JavaScript engine. So that's one of the exceptions. You will need to learn a bit more about how Fuzzily works to understand why he's doing that and so on. But yeah, we have really already a lot of good results just by using classical grammar-based fuzzing, and you will see it's not that complicated compared to writing something like Fuzzily that is definitely not that easy. So in our cases, today I want to introduce you to Dharma and show you how you can start to create some JavaScript file directly using Dharma. And my main goal for you is also to maybe motivate you to continue that at home and create your own grammar and maybe find some bugs with that. So Dharma is a generation-based context-free grammar fuzzer. So basically, you need to create a grammar, and this grammar will be used to generate some input. You can think it's really easy to install. I already provide you the stuff. I mean, usually you just need to do like pip 3 install Dharma, and that's pretty much all. I will make you clone the repository as well, but it's not mandatory. I mean, just because there is some grammar already inside. So if you want to analyze the stuff and so on, that's better. So quick introduction, a really tiny hello world. So just before that, there is a question. So let's pick the question. When picking a vendor to fuzz your product, are there any questions that are good to ask? Can they share fuzz report on open source software that have been fixed? I'm not sure I'm getting that properly. So yeah, typically what you can ask, okay, yeah, I got it. So usually when you are asking, so the question is, you have a product, you want to fuzz your product, or what should you ask? So basically, I think the first thing you need to ask is about the results they will provide you. Typically, if they are doing, so in that case, fuzzing, do they provide you the fuzzing harness, the harnesses? That means all the scripts and all the stuff they will write to try to find bugs on your software. Do they provide you those assets? Because clearly it's something really important, and you should then add that into your CI and run that continuously. You should also ask them to maybe provide you some code coverage information, all the files that will be generated during fuzzing. I mean, all the corpora that will be created during fuzzing. That's also really important for you to have that. I mean, you will not start from nothing. You will start with something. So really important. And then, regarding the fuzz report on open source software, yeah, I mean, they should provide you that. It's really depending of the company. For example, when I'm working with some clients, usually, so a lot of my clients are like blockchain software company, and usually they don't really want any report. They just want the bugs. So usually I'm creating some GitHub issues or providing them kind of GitHub issue alike with the sample, the reproduction, and so on, everything. And I'm giving them that, they are fixing the bug and so on. And at the end of the the consulting mission, I'm providing everything I developed in terms of like fuzzing harnesses, and they can just reuse that as they want. So that's usually the way I'm working. I know that a lot of companies are maybe not providing that by default, but yeah, sure, you should ask them to basically provide you everything to reproduce that and be sure you will not get any issue. To give you a quick idea, on web browsers, most of the bugs are actually bugs introduced inside the code base on the last year. Most of them, or during the last 6 months. So that's why it's really important to first continuously, to also have regression tests and so on, because that's what's happening actually. We have another question. What is your fuzzing server configuration, CPU and RAM for V8 fuzzing, and what is your recommendation? So you don't need to have something like OSS fuzz or cluster fuzz, where they basically have 10,000 of CPU. I mean, if you take a look at all the bugs that are reported on V8 and Chrome, most of them are reported by independent researchers and so on, or teams. And usually they got some server. So either they are using some AWS or whatever stuff on the cloud. On my side, I have a dedicated fuzzing tower. It's I don't remember there is 32 thread. I don't remember. Yeah, 16, something like 16 CPU, like physical one, or a bit more. I don't remember. It's a new one. Before that, I was using my own system. And in terms of RAM, something like 32 gigabytes, 64 gigabytes is good. The main issue you will have is you will need to have you will get a lot of CPU, but at some point you will need to scale. And usually that's not something that is scaling really well to fuzz Chrome or V8. So it's not because you will add 100 of CPU that you will get a lot of evolution on the single system. That's why it can make sense to have multiple instances. Something that some people are also using that seems to be working pretty well, I need to explore a bit more about that, is using Kubernetes and task on that. Seems to work. To be honest, I prefer to focus on improving my grammar and creating fuzzers more than optimizing on this part. I already optimized a lot of stuff regarding that. The more complex, the more interesting sample you are creating, you will find bugs. Even if it will be a bit slower, it's better to focus on writing and generating good inputs more than optimizing and executing a lot of them that are actually not that good. So yeah, focus first on quality, I will say, and then you can optimize that with quantity and speed. So I hope it was good for the question. So let's continue on that. So that's a quick introduction to Dharma. So just to show you, that's the hello world of Dharma. So as you can see, the grammar is pretty simple. There is 3 sections. The first one is the value section. So that's where you are defining the grammar, the different stuff that will be generated. We have the variable section. So for this example, we don't need it. And then we have the variance section. So inside this one, we define what will be generated. So let me show you that right there, hello.dg. So typically right there, we have the variance. So we're going to generate some main object, let's say. Those main object with, so we have the plus, meaning that we're going to take a look at the value section. So we're going to generate some definition. Okay, let's see how definition are defined. So we have definition, and a definition is actually the hello string. And then you have plus stuff. So some stuff kind of object value. We are taking a look at stuff, and stuff could be world or earth or Linux. So what that means is randomly, we will generate multiple definitions, and those definitions will be hello and then world, Linux, earth, randomly, something from there. Okay? If we run that, we can run that with Dharma grammar, and we are providing hello.dg. So we are not on the good folder. We are right there. So Dharma grammar hello.dg. So in that case, we are only providing generating one hello world, hello Linux, Linux world, and so on. So we are randomly generating some inputs right there. Okay. So the number of stuff that have been generated is some default value. We can actually modify that and so on. So that's really the basic hello world you will have. Let's make it a bit more complicated. We're going to introduce the variable section. So in that case, it's almost the same grammar. We have inside the value section, definition, stuff, and name. For the variance, you will see that it's always kind of the same. It's not that complicated. I mean, it's not changing a lot. And inside the variable section, that's where the new stuff is coming. So we're going to define one variable, in that case, my name. And what you can see is we are writing. So in that case, that's JavaScript. We can generate some valid JavaScript file already. And we have the at symbol, at my name, so that's the variable name, equal plus name. So plus mean we're going to take randomly one of the value name. So we're going to create some variable that will be inside those double quotes, and it will be something like that, that will be picked randomly during generation. So that's what we can see right there, var my name. And as you can see, we actually Dharma generate automatically some number to make the variable unique. So var my name 2 equal Patrick, and so on and so on. So it will create some certain amount of variable. And then what we can see right there on the variance side, so it will first generate all the variable, and then it will generate the variance. Inside the variance, we are generating some definition, console log, hello stuff, that is a value. So one of this one, my name is, and then as you can see, we are using a variable. So we want to replace that by a variable name. So that's why we are using the bang key, the bang character. And then as you can see, it will be replaced by a variable name that have been created previously. So that's actually a complex, complete example in that case of generation. It's a grammar that will generate some valid JavaScript file. So if we are running that, the argument I'm using, Dharma grammars hello variable.dg dash storage test is because I want to store the files that will be generated inside the test folder. And inside this test folder, I have one Oh, so in that case, it will be 1.html because I have not providing any, let me modify that, format JS. Let me just remove everything from the test folder. It's gonna be better. So I have nothing on my test folder, and then I'm generating a file. So I'm providing the grammar, I'm providing the folder, and then I'm providing the format that will be used, the extension of the file. Inside test, I have test1.js, this file. And if we take a look at this file, test1.js, we get something like that. So as you can see, my name, Bob, hello, Linux. So those stuff have been replaced by some random value that we define. And then my name is, and we specify the name of the variable. If we do that again, we're going to generate another one, Patrick, John Patrick, and so on. As I mentioned, we can also define how many we want, and so on. Do we have any question on that? So then this file can be processed, as I mentioned, JavaScript file. So it can directly be processed by D8. So we are using AddressSanitizer debug and the version D8, and we provide test1.js. And as you can see, the JavaScript file has been executed properly. Hello world, my name is Patrick. And if we take a look back at that, my name one was this one, and it has been replaced with Patrick. So that's good. We're able to generate some valid JavaScript file using a given grammar, Dharma grammar that is hello variable, this one. So if we don't have any question, typically one exercise you can do, and that's what I will do with you quickly for the live demo for this workshop, is basically to generate some file. Our goal will be to generate some advanced JavaScript file like this one, for example. This one comes from this blog post that is created by Amy from Red2 system. So, and in their cases, they found some ODay on Safari, and they got their own version of Dharma. I mean, at FuzzingLabs as well, we have our own custom version of Dharma to expand and extend the tool and add some extra features. And basically, they are using that to generate some JavaScript file like this one. So as you can see, some string one has own property, to string catch, and so on. So there is plenty of stuff. And they basically implement everything like the complete JS engine, like APIs that you can have. So a question, what if we find a vulnerability maybe with different grammar dictionary and the file are long, 2000 or 4000 lines of code, and we want to minimize to have a proof of work that work, but is also small? Good question. So for input minimization, there is some tools that exist. It's the first question you need to ask yourself is it a HTML file or a JS file? Because depending of the cases, that means when you will want to minimize it, you will need to execute it against a target, and it's going to be really slow if you are, I mean, if it's HTML and you need to execute that into like Chrome and so on. So that's the first question. It will not be possible for you to use all the whatever tools for that. What I can suggest you is maybe to create your own tool. I mean, if the stuff is 4000 lines of code, let's say one technique that is actually really simple is basically you are taking your file, you remove the first line, you execute the new file again, you see if you are still triggering the crash. So if you are getting the same AddressSanitizer bug, and you can actually detect that automatically with grep and so on. If it's the case, you take again the same stuff, you remove another line, and so on and so on and so on. So maximum in theory, you will maybe execute 999 case, and you will get at the end something that will be minimal, because if you remove a line of code that is important, in that case, you will not trigger the bug anymore, and you will not go deeper. Okay. So basically, our main goal will be to generate something like that in the long term, in the future. I mean, that's something that I'm inviting my attendees to the training to do on a long-term basis. That's not what we're going to do right now. What we're going to do right now is basically do this exercise, but for the object. So that's a specific JavaScript object. And I just want to do the demo with you and show you how it's done. And like that, you can just reproduce that with all the other one if you want, and just merge everything together and so on and so on. Okay. So that's the live demo. Let's copy this link. So that's this one. We have the object right there. So what you will see, so the best documentation you will have for what we are doing is basically the MDN, the Mozilla development. I don't know what the N means, but basically that's the documentation from Mozilla. That's kind of the reference for our JavaScript stuff. What you will see is that this object class actually can have multiple value. The value could be null, undefined, could be something, and so on. You have a constructor. You have some static methods, and you have actually a lot of them. Okay. You have some instance properties, some instance method, and so on and so on. You have also some example. That's really important. Yeah, that's pretty much all. So basically, our goal will be to create a Dharma grammar that will generate some JS object and actually call the different method of this object. So we can start with something really simple. Let's copy paste this example. That's the example from the constructor. So we can actually even go directly to the constructor. Okay. So as you can see, new object value. Value could be any value. We have actually some example. So we can perfectly start with something like that. So let me do that. We're going to reuse this one. So a quick question at the same time. Is it a good idea to use public proof of concept available for all bugs for fuzzing with some modification? Yes. So that's a technique that is possible. You can perfectly reuse some existing proof of concept, recent or even some really old one, and do mutation on them. You will not be able to do like simple mutation fuzzing. You will need to create some mutation fuzzer, and it will start for you to be complex, because that means since we are dealing with text-based format, you will maybe need to understand, to parse the file, to understand and get some abstract syntax tree, like exactly what the JavaScript engine is doing, and then modify those tokens and do mutation on that. Maybe switching from one constructor to another, changing the methods, and so on and so on. That's something possible. Yeah, that's something possible. Typically, to give you an idea, Fuzzily is actually using something like that the way it works, to make it really simple, one of the features is actually you will provide some JS file and it will parse them. It will convert that to Fuzz IAL, intermediate language, so his own intermediate language. And based on that, it will do some mutation on it. So it's similar and it's working really well. But that's one way to do the stuff. If your goal is just to take some proof of concept, do some mutation and providing that to the target, I'm not sure about the efficiency of that. If your goal is to, based on proof of concept, to learn some stuff, do some mutation on that, but more on the generation part, like leveraging on existing proof of concept to make better generation, in that case, that will be really efficient and really interesting. But just simple mutation doesn't really make sense. If you think of like bit flip, byte flip, or stuff like that, I mean, it's not interesting at all. It's just a waste of time for you. You're welcome. Okay, so in our cases, we want to generate some object. So let's do, let's making it simple, like object. We want to create some object. It will look like that. Okay. In terms of code, we can use let or we can use var. So let's use var, var object equal new object, and that's all. So we already have one way to create an object. We can actually do that multiple times and with multiple objects. As you saw, object can take multiple stuff. So we can put null, we can put undefined, we can use in the previous pages, there is a bit more example. So it can take any value. So you can even do that with Boolean or even Boolean like that, and so on. So our main goal in that case is just to create some new variable, and that's all. Okay. So it's not that complicated for that. Ideally, you even, since it's taking whatever stuff as an object, even better will be to provide it with maybe some string, maybe with some other object, and so on and so on. So you start to understand that typically if I'm doing the grammar for object, if I want it to be the more generic as possible, I will also need to make sure that basically the object I will create in the future will be dependent of some stuff. So in that case, since it can basically take everything as a parameter, a value, any value, I can provide that. I can provide it anything I want. So that's that. In that case, that's a more complicated, not the most simple grammar you can have, but yeah, that's the main idea. So that's good. We have an object. Then, since we have an object, we can actually call some methods associated to this object. So that's the constructor part. Let's see some static methods. We will not do all of them, but just the beginning. Let's say assign. So assign will copy some stuff, and you have the syntax. So you have object, assign, target, and then you have some other stuff that can be added. Okay, let's take a look at some example. Assign, target, source, and those one, as you can see, are object as well. That's some arrays. Seems to be good. I mean, either you can just put some hard-coded value, or even better will be to generate those value by yourself. So let's do something simple. We're just gonna call the method. So usually I'm calling that like object methods. And then we have assign. We need to use an object we create. So we need to use the bang character, target source. So that's good. For target source, we can perfectly generate some object as well. That's good. Let's say at least at the beginning, we want to have something that will work. We can perfectly do something like that. Okay. It's taking a target object. Okay. And yeah, we can just do like target. That's all. We implement the assign function. We can do that for some other function. This one is create. It will take some object as well, some prototype. And as you can see, there is an optional parameter. So that's really interesting for us because that's also mean we will need to create when we will do that, something like that. We need at the same time to use the one without the optional parameter and the one with the optional parameter. And so on and so on. So at the end, you will get something like that. And what you are looking to generate is some object method. So you want to generate some calls to those object. In that case, one of the issues is that in terms of statistics and probability, we have one chance to target assign, we have one chance to target create, and one chance to target create, but with some option. So basically, we have 2 out of 3 chance to target create. If you want to have something that will be the same, you can basically just put that right there. And do something like that. So in that case, you will you have the same chance to trigger one or the other, and in that case, you will get 1 out of 2 to trigger that. Again, property object, you will need to create the stuff. So in that case, don't forget in that case, I made a mistake right there because you need to have the plus because we're gonna pick some of that. And yeah, I think that's all. We have proto, so usually I will need to implement proto, properties object, and so on. Okay. So that's the live demo. To give you an idea for object, I create something like that just to give you an idea. We have the variable section when we are creating some object. What you can see right there is putting everything into try catch. So that's something I forgot to mention. Since what you're going to generate will not always be valid, you need to put try catch on mainly right there, just to be sure that one line of your JS that will be generated will not just stop and interrupt the execution of the whole file. That's something really important because when you are fuzzing something like a browser or V8, it will basically take some time to set up the stuff. Then you will execute the file and then it will shut down the process, at least with some, if you are not doing like in-process fuzzing. So it's really important for us to be sure to generate a file that will go until the end. Really important. So that's why we are putting some try catch. To be honest, those ones are not necessary because there is no way those stuff will fail since we are just creating some object with some value. Right there, you can see any value, null, undefined. Right there, I'm using common int. So that's some library, default library of Dharma, common, and then something. You have, you can see that I'm reusing some object right there, like an object that is created by another object and so on. So that's also, I suppose, why I put that into try catch. That's maybe the reason, whatever. You can see that I'm also creating some property because it seems that it will be needed somewhere. So in that case, right there, some methods will actually need some property. And even more, some methods will actually need properties. And those properties, as you can see, could be either null or either it will be like a repeat of property plus some other stuff and so on. So you have really plenty of stuff, and you can just make the grammar more and more complex. You can see for the methods that I'm actually just putting them like that, and I have object methods. So an object will be created, will be reassigned in that case. Again, that's more complex stuff. You can perfectly just do something like that, and it will be perfectly fine. Object, no, my bad. Something like that. Object dot methods, and we are calling the methods that are right there. That's actually even more accurate than this one. So basically, that will be the stuff that will be generated. It's inside the wrapper and so on. So at the end, what we will have is, let's do Dharma, grammar, object.dg. And what you can see is we have some try-catch that will basically create some object right there. And then we are using those objects at this moment. Okay, object. So it's reusing some existing object. So the grammar in that case is not really that generic. It could be even better to create some object at this moment, put like any value. In that case, create is not even dealing with the optional argument and so on and so on. So as you can see, even this one have plenty of stuff to be improved. So that's good. What we can then do is actually generate multiple files, and that's something that is really nice with Dharma. So let's generate. So typically for this file, we can also give it to D8. Don't remember the name. Oh, I have not stored it. So Dharma storage test format JS. Okay, so it's inside test1.js. So that's the file, and then I can basically give that to D8 test1.js, and it's running well. All the stuff is not actually running well. I'm pretty sure there is some stuff that are failing. Actually, we can even give it a try. This one, let's see what happens if I'm removing all the try and the catch. I think we are good. No, not really. Okay. So if I'm removing all the try catch and trying to execute that again, as you can see, new object. So it seems that something is failing. This stuff is not defined. So that's actually for testing, that's good, because that means I've made some mistake on my grammar. So let's take a look at the grammar again. It's saying that it was on variable object1, so during the constructor, and it was any value, maybe. And any value was this one, any value common text. And I forgot to put that into some quotes. So that's why I'm getting the stuff that is failing. So usually what I will generate at the end will, in that case, be more something like that. Okay. Let's try to re-execute that again. Define property is not a function. So that's interesting. Again, it seems that this function is not a function anymore. At least when I create this grammar some times ago, it was a function, but maybe the stuff actually evolved. Weird, because as you can see, object define property, it's a method, but what you can see right there, it's object dot define property. So we are not calling this function in the same way than the other. So in that case, for my function to be good, it should have been something like that instead. So that's also mean what I told you that I modified right there was not good, because depending of the function, it could either be something like that, object dot plus method, or it could be the other way. So there is really plenty of stuff that can be done, as you can see, even for testing. In that case, you can see that there is an issue with my grammar. There is, I will say, two ways to create a grammar at the end. Either you can try to focus on only generating some valid stuff. So that's basically what we are doing right there. Either what you can also decide is to put some randomness. Typically, that's what I've done right there. Some of those functions will actually be rejected because they need to be called like that. And some other will be rejected when I'm doing that because as you can see right there, it's undefined and it's not supposed to be called this way. So that's some randomness that I choose to add to this stuff. But I mean, that's really up to you. And that's also why it's really interesting for you to write your own grammar, because since we are all thinking differently, and that's also why people start to continue to find bugs and so on, even using the same tools and the same targets. It's mainly because we are implementing fuzzers and interpretation of what we are reading differently. So that's really interesting. Any question regarding that? So usually you will, so that's basically the stuff. You have the variants with some wrapper, some try catch I mentioned. You can even have the constant max repeat power. So you define how many lines you want to generate. I will let you take a look at the rest. Something important is we can generate multiple files inside the, so let's say I want to generate that in the GS0. You will understand why right after I choose this name. Count 100. I just generate 100 files inside this folder. Right now, I will do the same with GS1. Count 100. So right now I have inside my GS0, I have 100 file, 101 in that case. No, because there is the current folder as well. So 100 file. Then what you will need to do is actually provide those newly generated file into your target. So into D8. You can perfectly create a simple bash script. That's perfectly fine. I mean, that's working. What you will need to know is when you have a crash, basically, you will get AddressSanitizer and the error code will not be the same. Give me 1 sec. I will try to find you an example for this specific target. One file that can actually make it crash. Yeah, maybe this one. I think, yeah, this one is vulnerable to this one. Oh yeah, I don't have any crash for that, just for the JavaScript online. So whatever. I got some for the rendering on this one. So whatever. So basically, when you have your JavaScript engine that will D8 that will crash, you will get a stack trace, an AddressSanitizer stack trace. And if you are doing echo $? In that case, you get the error code 0 because my previous command was actually a success. But if it's a crash from AddressSanitizer, this value will not be 0. It will be something negative. So you can perfectly create a simple bash script that will detect that automatically and just do the command line D8 with the file, check the return code. If it's good or not, you are storing the file, you detect a bug or not, and so on and so on. During this workshop, I chose to provide you a Python script. It's this one. So this simple script. So let me show you that right there. Again, it's not complicated. I think it's a good start also for you to play at home. We are doing some start time. It's just to monitor how many execution per second we have. That's the total number of cases we execute. So I will discuss about the worker right after. We define the path to D8. So it is this one. Then I choose to create two threads. So they will use those two workers with some thread ID and the path of D8. It will start, and that's all. So that's some simple multi-threading on Python. And then we have the worker, that is our fuzzing thread, basically. We are printing the working ID, so it will be, in that case, 0 or 1. We are looking for the file inside the specific folder, GS, in that case, 0 or 1. We have a certain amount of files, so 100 in both folders. We are doing some prints for each file, so we iterate over all the inputs we generate. We're going to do a sub-process popen of D8. So we're going to basically do a popen of D8 against the file name. We're going to monitor, we're going to drop the std error and even the std out inside a dev null because we don't want any noise, but it doesn't mean we will not get the proper return code. It will be the good one. That's what we are checking. We check if the target crash, if it's different than 0. If it's the case, we are printing the error code and the file name, so we have the information. Ideally, you want to improve this further. You want to add, you want to store automatically this file into like a crash folder just to be sure you will not overwrite it. Maybe you want to, inside this further, to do the generation of Dharma at the same time directly inside. Maybe you can ask directly the thread to generate some file and then run the further and so on and so on. I mean, you have plenty of stuff that can be done. The final part of it, you increase the number of first cases you have done, and basically you monitor how long the execution took just for us to get some statistics. So that's the kind of script. Maybe the scripts are similar, are familiar to you. If you maybe watch the video of Gamozo Labs, he creates this kind of script. I find it really clean and really detailed with all the commands. So that's part of his job in that case. So let's run the fuzzer. So in that case, we have some file inside GS0 and GS1. We're going to run the Python fuzzer, Python 3. So in that case, I have not dropped the std out just for you to see what is happening. Maybe, I mean, we will see. We have fuzzing D8, and that's all. We are running the stuff. And as you can see, it detects 100 files in this corpora and 100 in this other one. First cases per second. We can see that we have currently like 24 first cases per second. So we are running with 2 threads at the same time. You can perfectly add more threads and so on, and you will get more execution speed per second, of course. If we if we change that, for example, it will re-execute the same file, but it doesn't really matter. We can see that, yeah, we are getting an average of 12, maybe 13 first cases per second. So yeah, we can see that the scaling is not already really well in that case. Also, it's not that much, but it will be even worse for you later because basically the files that are generated right there are really small. They are looking like that. It's really not that much. Usually, you will like to generate really huge file with a lot of different stuff inside because your goal is also to generate some complex file and not just some simple file. So you have all the command lines right there. And yeah, don't forget that the more complex the file is, that means the more code you will also execute. And just to give you a quick benchmark on some, so I don't remember what I was generated, but basically with 60 lines of code, it was 30 exec per second, meaning that if you are doing a ratio of line of code per second, you have something like 1,800. But if you generate 200 lines of code with only 10 exec per second, at the end, you are executing more line of code per second. So it's not that important that you have some slow exec per second, because it's not a good metric, to be honest. What is really interesting for you is the number of line of code you execute. Also, same way, depending which API, JavaScript API you are targeting, it's going to be more slow. One will be more slow than another, and so on. So again, that's not the metric you need to take care of. What you need to take care of is if what you are executing is interesting, interesting for the V8 engine, and how many line of code, how many JavaScript line and API you are calling, basically. And that's all for this workshop. Do we get any question? So I hope you learn a lot. A question? Yeah, perfect. Thanks. AddressSanitizer question. Have you ever compiled a software with custom ASAN interceptor? They are useful when the target software has its own allocator implementation and you want to detect corruption to avoid. Yeah. I couldn't find any practical example online to write one. Yeah, exactly. So I have not done that myself, but if I remember, maybe search for AddressSanitizer and interceptor regarding Rust, because so it's not the case anymore, but previously, like 2 years ago, the guy who was, when we was doing some fuzzing on Rust, the allocator was failing and detecting some false positive, mainly because of the allocation library that was used in Rust. So I remember that there was some custom allocator, custom address detector, AddressSanitizer detector. But I think that's the only case I saw, to be honest. Most of the case, the stuff is working out the box. Do we learn how to exploit the phone bug crashes? No, you will not learn. So I will, in the training, I'm discussing how to do like all the exploitation of those bugs are working mainly on V8 and Chrome. That's not the goal of the training. The training is really focused on fuzzing vulnerability research on browsers. So my goal is for you to basically at the end of the training be able to fuzz all the different components of mainly Chrome, but also the other browsers to find vulnerability. So with AddressSanitizers and so on. Once you got the bugs, it's up to you to develop an exploit and so on. There is some really good trainings that exist on that, especially the one from Amy that can teach you how to write an exploit for JavaScript core. She's an expert on that. I'm not an expert on exploit. I can say I'm an expert in fuzzing, but not on exploit development. So that's why I'm not teaching you that during the training. It's a whole training on itself. Will we get a copy of the demo files along with the slides? Yeah, I will provide like a complete package of everything. What is your opinion on context-aware fuzzer for JS browser versus context-free? Do you see significant improvement or not? In my opinion, context-aware fuzzer work well. How to say that? I prefer context-free for depending of for rendering engine and JS engine. I prefer context-free because I'm using Dharma all the time, so I know how to write the stuff and so on. And over the time, you just grow your database of grammars. So the more you are doing that, the more knowledge you already have the more knowledge you already have. For context-aware fuzzer, you can think of like Fuzzily, for example. It's working really well. Again, I mean, Fuzzily got some really good results. So it starts to make me think that it's maybe a good shot. What I think it's more the reason why Fuzzily was working better is not the fact that it was like context aware of like doing some coverage guided fuzzing and so on. It was not that. It was more the way it was generating the stuff and the way it was executing against the target. That was more interesting. What can be done when you want to write a fuzzer? If you want to really write a fuzzer that will be really optimized for JavaScript engine, what I would suggest you to do is to do snapshot fuzzing, but it's definitely not something that beginners can do, and it can make sense in that case to start to build on top of that. Oh yeah, thanks Javier for the link. What do you think are important prerequisites to grammar-based fuzzing, stack corruption, incursion, JavaScript knowledge? I mean, to be honest, you don't need to have so much prerequisite. I mean, as you saw, the main goal, and actually I learned JavaScript by doing that, like reading all the different building object and creating Dharma grammar for each of them and so on. So to be honest, the prerequisites are not that important. We even automatize part of it by like passing MDN just to pre-generate some Dharma grammar, and then we are going manually to the stuff and improving the stuff with my team. So it's not, to be honest, that's not cool. That complicated. And again, the more you learn about the target, the more interesting stuff and weird stuff you can do in JavaScript, you will start to implement. Typically, as I mentioned right there, for the object, you can see that in some case, a function will create a new object, and in some case, it will maybe not. So right there, if this function is creating an object, for example, I'm not using that at the maximum of these capabilities, this function, because this function is just using some object as an input, but ideally, I can also just create a new object from scratch. So something like that. It will be fine. I mean, null is an object, so that will be, null will maybe be not valid, but I can perfectly do something like that, and it will be fine. It will be another way to call the function, and maybe this function is actually returning a value, and this value is maybe interesting, so maybe you can put that directly in the variable section. If this stuff is generating an object, why you are not just doing something like that? And so on and so on. So the more you learn about JS APIs and stuff you can do with JavaScript, the more you will upgrade your grammar and just make it more complex and trigger some weird cases. Also, some JS API are really interesting if you are looking for some kind of bugs. You can think of for example, you have some APIs regarding a media library and stuff like that. All those stuff are using a lot of context. Typically, those contexts can be cast from one type to another, and there is plenty of type. And this kind of stuff is just gold if you are looking for, I don't know, like use after free or stuff like that. That could be really interesting. So there is some APIs that will be more interesting than some other for some kind of bugs, but I mean, you will just learn that with the time. Do you plan to provide full online training, or it will be only available on site? For the moment, only on site during conference. I'm planning to do online, but I'm planning either to record it in video, doing it online, For the moment, at least for 2022, it's just on site during conference. So next one will be Ring Zero in Las Vegas, but and maybe some other one during the years, maybe some online training, but this training requires a lot of interaction with attendee. It's really important. It's really intense. I mean, in 4 days, I really have a lot of stuff to tell you and to show you. So if I'm doing that on a full online version, that's also mean in terms of time zone, it could be complicated. So it's starting to be to add complexity, and I will not be able to just remove part of the training. I mean, there is 5 modules. First one, introduction to browser and fuzzing. Second, rendering engine, fuzzing HTML and stuff like that. Third, fuzzing JS engine and JIT compilers. Fourth, fuzzing WebAssembly, parser and APIs and so on. And finally, the last module is about all the other stuff. So you have IPCs, UI, media library, a PDF renderer in like PDFium, the PDF rendering stuff in PDF library, in Chrome, and so on and so on. So as you can see, there is 5 modules that need to be done in 4 days. So that's complicated. So that's mainly why, and maybe in the future I will do the recorded video like I'm doing with my other trainings about Rust, Go, WebAssembly, reversing. All those ones are already in video, but they are tinier training. They are only like 2-day training. They are not like 4-day training like this one. That could even be more 5-day training, to be honest. Thank you for the workshop. Thank you. Awesome. So thank you for your comment. I hope you appreciate. And yeah, let me know if you have any question on the chat. I mean, you also have the Discord. I mean, you can directly contact me. Cherry will deal with the package that I would give her, and she will handle the delivery for you guys. And yeah, if you have any question about the training and so on, yeah, just reach out to me or Cherry, and we will be happy to answer.
All right, thank you, Patrick, for this awesome workshop.